find the same way. Look at this, sine 45 degree or sine of pi by 4 or cos of pi by 4. Same thing here. If you are making a 45 degree, draw perpendicular from here to here. And same thing, if this is 45, that means this will be 45 as well. So if that means this side and this side will be opposite. This picture doesn't look clear, so you can find out the value of these either using the triangle approach or right angle triangle approach, or you can use the unit circle approach. Both are actually the same thing if you look at it, because eventually you are drawing a right angle triangle only. This is inside the circle, that's it. So this is your radius, you are making 45 degree. This is 45 degree. If you draw a perpendicular from here to here, this is 45 degree too. And this is 90 degree. This is your radius, and you don't know what is the value of this and what is the value of this. But you know that this is an isosceles triangle. So this side and this side will be same. So let's say this side is K and this side is K. So from this, you have the magic formula. You can say, okay, this is R of cos 45 degree and this is R of sine 45 degree if you have to find out the x and y coordinates. But assuming you don't remember the value, you can still see this is an isosceles triangle, which is a right angle triangle also. So this side and this side will be same. So again Pythagorean theorem applies. K square plus k square equals r square. So 2k square equals r square. So k equals r by 2 is square root. Sorry. No, not 4. Sorry, my bad. 2. So 2 comes here. So k square equals to r square by 2. So k equals square root of r square by 2, which makes it k equals 1 by root 2 times r. So this is 1 by root 2 times r. This is also 1 by root 2 times r. So from this also you can find the value of the x coordinate and the value of the y coordinate. If you visualize this as a coordinate plane. So this becomes r times 1 by root 2 and this becomes r times 1 by root 2. X and y coordinate. So you can if you remember the value of sine cos 45 degree, you can find out the coordinates straight away, or else you can go the orthodox way to find out the length of these sides and then correspondingly find out the x and y coordinate. So let me stop here and see if there's any doubt. It's okay. There's no question as a bad question. So anybody having a question or a doubt, please feel free to ask. Yes, Ishwari.
So in the unit circle, I didn't get, because when there's a 90-degree triangle, I didn't get would the other two angles be 45 degrees and 45 degrees?
Yeah, so look at, okay, so basically if you look at, let me draw a bigger circle. Hope I can do a better job. Okay, this is my circle. Okay, so when I'm trying to draw 45 degree, meaning I'm making a 45 degree angle here. Yeah, so this angle is 45 degree. Fine.
I meant as in a 90-degree angle.
So yeah, so basically what I'm doing is I'm drawing a perpendicular from here to here.
No. Instead of the 45-degree angle, it's like a 90-degree angle.
Okay.
A 40 circle.
If you so you are going one step ahead of what I have taught so far. So if it is 90 degree angle, okay. See, using the unit circle, you can find out the value of sine and cos also. Okay. sine of 90 degree and cos of 90 degree. Now you made a 90 degree, meaning these are two radius, this radius and this radius. Yeah. And then you just join these 2 points. Okay. So in this case, this is 90 degree. Okay. What will be the value of sine 90 degree? So this is a theta, right? This is the angle that you are taking into consideration. So sine of that angle is always the side opposite to that angle divided by hypotenuse. Yeah. So the beauty of the problem is your side opposite to this angle is let's say this is k. Okay. Divided by hypotenuse. Interestingly, k is also the hypotenuse. So both have the same value. So the side opposite to this angle and the hypotenuse both are same. So that is how your sine 90 becomes k by k, which is nothing but 1. Yeah.
So would the coordinate at 90 degrees, it would be 0, comma 1.
So here, yes. So now you visualize this. Now you look at this is a coordinate plane. This point is nothing but your where the value of x is 0. X on this line, if this is your y coordinate, y axis, and this is your x axis, every point on this line will have x equals 0. Correct?
Yes.
So this point is what? R times cos of 90 degree, and this is r times sine of 90 degree, the y coordinate. Yeah. Look at this, r times cos of 90 degree. Cos 90 is how much? What is the value of cos 90?
0.
0. So see, everything relates. The dots are connecting here. Here, cos 90 is 0. So r times cos of 90 is 0. This is 0. X coordinate is 0. R times sine of 90 is what? 1. So your x and y coordinates here are 0, comma r. Yeah. And in a coordinate plane also, if you see on the y axis, if there is any point or anywhere on the y axis, the x coordinate is value 0. That's what you are getting here.
But if the circle's origin wasn't, the circle center wasn't at the origin, could we still use this to find out the...
100%. You can always. So this is, see, these are your coordinates, and circle is somewhere here. Okay. So then, what you have to do is, you have to find out the x and y coordinate. Let's say this one is x and y coordinate. Okay. So you have to always visualize this like this. Your x coordinate value will be how far is the center from here plus this length, which will be r times the cos of theta. Okay. So this length is what? R times cos of theta, whatever is the angle here. So the x coordinate will be this distance, meaning how far is your circle from the origin. Let's say this is x. So it will be x coordinate will be your x plus r times cos of theta. What will be your y coordinate? It will be, let's say this distance is y, or let's for sake of simplicity, let's say this is 5 centimeter away from here. Okay, and this is, let's say, 6 centimeter away from the origin. So this becomes 5 plus r cos theta, and your y coordinate will become 6 plus this height. So 6 plus r times sine theta. Yeah.
Yes. And if it was at like 250 degrees, because the unit circle has like other angles,
Yeah.
we would use the same formulas, because some of the angles would be the same, like 180 is...
Yeah.
is like the same portion.
So I have not gone beyond the first quadrant yet, right? So far we have only looked at the first quadrant, right? That is where we looked at 0 to 0 degrees, 30 degrees, 30 degree, 45 degree. Let me not write side. 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. This is what we have looked at. So basically, we have looked at only the first quadrant. If you are talking about in your unit circle, if you are talking about this angle, now it is left to how you visualize this. If you look at this, let's say this is your x and y coordinate, okay? If you're talking about this, again everything remains the same. You join this, you get let's say this is 120 degree, okay? So how will your calculation work? You are actually flipping it, and you will, instead of drawing a triangle like this, you will draw a triangle like this, and then your x coordinate is going in negative direction, y coordinate is going positive. Your calculation still remains similar, but just that you are taking a mirror image of that and you are looking at it from this side.
So it's like a reflection over
it's
the
a reflection of that one, correct. Similarly, if you go to the third quadrant, if you are talking about 220 degrees or 235 degrees, then you know how you are going to visualize this. You will not try making a right angle triangle like this, right? Because that doesn't help you with the x and y coordinate. Your x and y coordinates you can derive by, you will derive your x and y coordinate against the x and y axis, correct? And that is why you will use again another reverse reflection method to visualize how your x and y coordinates would be, and you can as well see that, okay, if it's 220 degree, so eventually you are falling in the third quadrant where your x and y value will be negative, right?
So could we also dilate the point to change? Because if you're reflecting it over the y-axis, wouldn't the point would still be the same? It would just, the value would just change.
So basically you will not worry too much about the positive or negative values to begin with. You will just look at this as a right angle triangle, and this is your base, this is your height, and this is your hypotenuse. Let's say this is your angle you're talking about. So you will, if you're talking about let's say 235 degree, so this is 180 plus 45, and you are limiting your visualization to this particular quadrant where you will not look at this as 225 degree, you will look at this as 45 degree in the negative direction, and then this becomes your right angle triangle. You will say, okay, this is 45 degree, this is my length, and this is my height, and this is my hypotenuse. I will look at this in isolation as a right angle triangle, and whatever value I get, okay, I now know that, let's say if I got this as 4 centimeter, so that means 4 is here negative. It will be, my y coordinate will be minus 4. That's what I'll put. I'll get the absolute value, and then I'll look at which quadrant it is falling in, and then put a sign against it.
But so sorry, I meant translate the point, not like reflect it. Because if the triangle was reflected over the y-axis, then wouldn't we just multiply the y coordinate by like -1?
Right. So again, I'm not sure if I'm getting the question right, or if I'm interpreting it the way you are envisioning it, but I will still keep it simple. I will say this is my coordinate plane. I have to visualize where my triangle goes by changing the angle, which quadrant it is falling in, right? And then I will look at this as a right angle triangle in isolation, and then I will put it. If my angle is such that it's falling here, I will look at this right angle triangle in isolation, find out the height and the base, I mean A and B, and then hypotenuse, and then I will do the absolute calculation, and then I will figure out whether which of the x or y coordinate is negative or positive, and I can relate that. Yeah.
Okay, thank you.
Anybody whom I have purposefully confused, please go ahead. Chris, Dave, Arya, Raj, Rehan.
So far, I understand everything, sir.
Okay. So I've not been successful in confusing you guys, right? My bad. Rehan, are you with me?
Yes.
Okay. Chris, Dave.
Yes, sir.
Okay.
Yes, sir.
So one thing, right? I mean, as a very simple takeaway, if you look at geometry, geometry as a subject has a lot to do with how you visualize things. I mean, everything originates from the very basic concept of knowing the properties. See, the Pythagorean theorem is such a strong theorem that will remain glued with us for the rest of our life. Wherever we come across a right angle triangle. And that becomes your savior for solving a lot of things that you deal with in terms of trigonometry. Right? So the whole topic trigonometry revolves around this cute looking triangle, which is not cute anymore. Yeah? So as long as your understanding of the key concepts of trigonometry or the right angle triangle, knowing the property, how they relate, how the sides relate to each other, is understood, you will have no issues. If you're talking about unit circle, I never felt a need for understanding unit circle. Okay, there's nothing different. We're not talking anything different. Only thing I found interesting was if I have a circle and I'm making an angle here, how do I find the x and y coordinate at this point? That is where I found it relatable with whatever we know. And we can say that okay fine, r times cos theta and r times sin theta. That's the only new concept that I found relevant for you guys. Otherwise, whatever we do with the unit circle, it's nothing but a repeat telecast of what we have learned with basic right angle triangle. It just helps us visualize that in a different way. Yeah. So I was planning to cover only the unit circle and how to derive the values or how to find out the coordinates in the first quadrant, but apparently thanks to Ishwari, she dragged me to all the way till third quadrant, and I'll not be surprised if she pushes me to fourth quadrant also. So same thing, nothing different. So all that you see is, if you are talking about angle which is okay. So now let's do a fun exercise. Okay, let's see 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 120 degree, 135 degree, then 150 degree, and 180. Oops, I should be using the board better. So okay, I hope you guys can see it. Okay, 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, 120 degree, 135 degree, 150 degree, 175 degree. No.
Doesn't it
No.
go to 180 degree?
Yeah, it still goes to 180 degree. My bad. Good. Now let's see what all we can find with whatever we know. Okay. Let's see if these are relatable or not. I'm talking about sine, cos, tan. And let me keep some space for ourselves so that we can play around with this. See, mostly during my childhood days, I had focused more on angles to 90 degrees. While I'm teaching you guys, I'm finding an opportunity where I can go all the way till 180 or beyond that also. So we are right now doing a fun exercise to see if we are able to find out the correlation among what we have seen so far to get the value to fill this table. Let's see what all we are able to fill. Sine 0 degree, who all knows? Who all remembers? How much?
0.
0. Okay, sine 30.
1/2.
I want everybody to participate. So Ishwari, I'm not discouraging you, but I'm trying to encourage everybody else. Dave, how much is sine 45 degree?
and 45 degrees would be 1 over 2 squared.
Yeah, square root 2, 1 by root 2. How much is sine 60 degree? Arya? Sine 60 degree.
Sorry, you're glitching. Can you repeat that? I can't see the screen.
I'm asking how much is sine 60 degree? Can you guys hear me okay? Or is it only a problem with Arya? Ishwari, Chris, Dave, Rehan.
I can hear you, okay?
Yeah, I can hear you.
Arya, are you able to hear me okay, better? Okay. So Arya was blaming me for me glitching. Now I have an opportunity. I will tell her. Seems network issue.
Can you guys hear me?
I can hear you now.
Okay, I can turn off my Wi-Fi.
Okay, so yeah, so coming back to Arya. So Arya, do you remember how much the value would be for sine 60 degree?
Yes, sir. I think it's root 3 over 2.
Okay. How much will be sine 90 degree, Chris?
1.
Okay. Now we'll go to 120 and all that, okay? And we will try finding it out. So let me make a circle here. Okay. So I'm just keeping this for your reference, okay? Now if I'm talking about cos of 0 degree, how much it is? Ishwari?
Sorry, 1.
1. How about cos of 30 degree, Rehan?
Square root 3 over 2.
Root 3 over 2. How much is cos of 45 degree? 1 by root 2, Dave? Same thing as sin 45?
Yeah.
And cos of 60, let me not waste your time, I will just write it down because you guys can hear it relate. And 10 I'm not filling because sin by cos is 10, so we'll not worry about that. Now tell me, how much would be sin of 120 degree? Sin of 120 degree. This is where this unit circle will actually help. Now, sin of 120 degree means what? Here. This is 30 degree and this is 90 degree. So, sin of 120 is, this is your x and y coordinate. See, your x becomes negative. When you say sin of 120, you are going to the second quadrant and that is where x becomes negative. Right? So, you are essentially looking at this is 30, so this is 60. So, sin 120 degree will be equal to sin of 60 degree in negative x. Yeah? So, if you look at this one, what is that? This is 30 degree. So, when we go here, so okay, so this is 30, so let's say 120 degrees, 90 plus 30. Let me not draw a triangle here, I will draw a triangle here. So this is 1 by 2 of the radius and this is the radius. But this value of this x is minus r by 2 and by the hypotenuse which is r. So this becomes minus 1 by 2. So basically what you are seeing now is when you are going to the second quadrant, now everything, the sign of that value would be negative of what you are seeing here. So from here, this became, this part is radius by 2, so this is sin 30 is 1 by 2, minus 1 by 2, and then the same thing repeats. Yeah. So if you look at sine, the behavior of sine, where the unit circle helps is, if you're talking about the angle here, less than 90, it's all going positive. As soon as you went beyond 90, the same value, 90 plus that value. So whatever you had here, 120 became 90 plus 30, and you saw that value of x is actually becoming negative. So this unit circle actually helps you find out how do you get to that value? Okay, so this is where you see this becoming negative, because here no, this is no, the sign of whatever value we are seeing, that all became negative. Is it digestible?
Yes,
Oh.
sir. It's making sense.
Okay. Similarly, now what you will see is same thing happens with cos, but interestingly, the cos will stay positive in the second quadrant here, because your value of y, this value is positive still. So here cos will not become negative. Cos will be all positive. It will just repeat. So cos 30 root 3 by 2 remains root 3 by 2. Okay. This remains 1 by root 2. This remains 1 by 2, and this becomes 0. Yeah. Yeah. Correct. Yes. So basically, see how unit circle is coming to to help us is only to when you have to look at what happens when you go beyond 90-degree. That is when you take reference of unit circle, and that helps you get the corresponding value of this one. Okay. And now once you have sine and cos, you know anyways how to find out the value of 10. So I'm not going to that. But out of excitement, we have covered what we were wanting to cover in the future classes also. Because I have all reasons to blame studies. So I had planned pi by 6, pi by 4, and pi by 3. How to find out the value for these three, which is pi by 6 is nothing but 30, pi by 4 is nothing but 45 degrees, and pi by 3 is nothing but 60 degrees. How to find out the value of these angles using the unit circle. But now since we went little beyond what I had mentioned as a plan for today, we have covered up to basically pi. And if I have rushed through it and made any mistake with anything, I am only doubting this way. Why would cos 80 be 0? Because it's base.
Is it because it would be
a straight line.
I, so it would be on the
Yeah.
x-axis, and so the y value would be 0 and
What?
9.
Yeah, correct. Yeah, no, I mean, I was just doubting myself with this one. But yeah, this seems to be okay. But we are not trying to memorize anything. But only thing will happen is from for you guys, I don't think you have a strong reason for memorizing all this. You have learned how to derive the value, but still it's easier because these are very commonly used angles. So if you remember the value of sine from 0 to 90 like this in these batches, then everything else you can relate, because cos is just a reverse of that, and then you know how you can visualize. So tomorrow if you have to find out sine of, let's say, 235 degree or 225 degree, then you will just visualize this as okay, this is 90, this is 180, and 145, 225 is 45 degree here. So when you come to this one, then you're looking at this triangle to find out what happens to my x value and what happens to my y value. Here both are negative. So here you will see, since your x and y both are becoming negative, so you will see corresponding change in sine and cos. Basically, if your x value is negative, that means your cos theta will be negative. If your x value is positive, then you know this is 45. So if this is 45, yeah. So the cos will be negative in this case. Here we will see all positive because we were looking at this as angle, now here looking at this angle. So basically you have to just visualize this. Don't go by what I'm saying exactly. You have to look at how exactly you're traversing to make that angle and which angle you are considering to find out the x and y value, and correspondingly you would be able to relate it with this one. Okay?
Yes.
Yeah. So we already top of the hour. Any questions before